Now. Hello to everyone joining us from around the world and all ships at sea. Welcome to hour one of our 3-hour ECL workshop at Community Day 2022. My name is Bob Foreman, and with me today is Hugo Watanuki. We are both part of the ECL training team, and we are very excited to present this year's theme, which is ECL Alive, a deep dive into definitive HPCC systems. In this first hour, we're going to be looking at the ETL way with ECL, data ingest, profiling, hygiene, standardization, and finally, exporting. Now, we're excited because this workshop is based on a new book by Richard Taylor. Now, as you can see on the right side of this slide presentation, you see a volume 1 book, and this one has been out for several months now. This was the Definitive HPCC Systems volume 1, which is the overview and platform setup. Well, I'm happy to announce that as of this month, we have now volume 2, data transformation and delivery, which is available right now on Amazon. And the links below are shown on this slide. We will also be providing the links in the chat of our presentation. So in hour number 1, we're going to be skipping ahead of chapter 1. We're going to be going into chapters 2 and 3. Well, what is in chapter 1, you might ask? Well, chapter 1 is an introduction to ECL and again, the HPCC systems, kind of a review of some of the items that the author Richard Taylor talked about in hour number 1. I'm sorry, in volume number 1. So in this hour, we're going to be talking about chapters 2 and 3. Chapters 2 is titled Getting Started with Your Data and covers data ingest, data profiling. And then chapter 3, we're going to wrap up this first hour with a look at working with your data and the concepts of data hygiene and standardization, also data exporting. All right. And also at the end of this slide presentation, you'll see a link to a repo where all the ECL code that we're going to be talking about will be available. So let's get started. The term spray has been around HPCC systems now for about 20 years, since its inception. But as of ECL Watch 9, which will be released at Community Day, available to everybody, and also available as a tech preview, the spray has been replaced with the word import. So spraying import is a process of copying data from the external world onto the HPCC cluster. And it's appropriate because the environment always works with distributed data files. So that's where the term spray first came from. Although now we're migrating now in the later versions, ECL Watch 9, to the word import. All right, so to get a single physical data file onto the cluster, the spray and import process, first of all, divides the data into n number of chunks, which n is the number of nodes in your cluster. And we try to divide each file part into as closely evenly sized to be stored on each node. So each node can be doing the equal amount of work. And before any file can be imported, it must be first in a location that is accessible to the cluster. And we call these locations a landing zone or a drop zone. And this landing zone and drop zone is another middleware component that was described in volume 1 of this book that talks about how to set one up and how to use it and how to access it. Here's kind of a visual description of what we just talked about on the last slide. To our left, we have here the landing zone. I'm just going to zoom in real quick. You can see the landing zone has different types of file formats, from a fixed file format, fixed record, to, well, I'm going to skip the limited for a minute, variable, which is a variety of IBM formats that you don't see used too much anymore. XML and JSON, which are popular formats, as all of you are aware of. XML for extensible markup language, JSON for JavaScript object notation. And we're going to be focusing on the delimited spray, which is kind of, to me, a coverall. For just about any file that you need to get on the cluster. If any of the others don't fit, well, the delimited is your go-to spray option. Now, spraying is so important, or import is so important, that there's 3 ways to do it. You've got ECL Watch, which I'm gonna show you on the slide here coming up. We've got an ECL work unit where you can drop in a library file like spray fixed or spray CSV or spray XML and call your spray operation programmatically. And also we have a command line tool called DFU Plus, which also you can issue spray commands on your command line interface. Now, once the spray operation begins, you'll see that it takes that file on the landing zone and divides it into as equal amount of parts as possible. And the beautiful thing for you as an ECL developer is after the spray, it doesn't matter how many files it's divided into, how many physical parts. We always reference the file as a single logical file in ECL. All right, so let's talk a little bit about the data that we're going to be working with in this 3-hour workshop. We decided to use a popular public data set that is available called the New York Taxi and Limousine Commission, which makes its trip data freely available to everyone that wants to use it. And there's a link there in that first paragraph on this slide. Now, in the book, the author talks about that there was a migration from previously storing this data as delimited files or comma-separated value files into a new, well, Python format called Parquet or Parquet, whichever way you want to say it, Parquet. So anyway, there's things in Python you can do with 1 or 2 or 3 lines of code to convert those Parquet files over to CSV. There's also some utilities that you can download online. We're going to make it easy for you in this workshop. We have already converted for you 2 files from January and February of 2017. They're comma-separated value files ready to spray to our HPCC cluster. So step number 1 would be to upload those to your appropriate landing zone. And then once they're uploaded to the landing zone, we have a spray option. I'm going to zoom in on these. To the left, you see the new import option that will be available in ECL Watch version 9. And so you can see a little bit different kind of format. The legacy format shown on the right here is actually showing you, well, we've added a target scope called DG, which is abbreviated for Definitive Guide. So all of our files we're going to be working with in the workshop will start with a prefix of DG, which is significant. You'll see in just a couple of slides coming up. So really, the only other thing that you need to change is the checkbox on the bottom here called Record Structure Present. With looking at these files coming in and looking at the documentation for the New York City taxi and limousine data, we find that the field information of these files are located in the very first record of these comma-separated value files. So we enable that, which allows the ECL Watch then to read that data on the first record and create a record structure for us inside of the ECL Watch. All right, so that's the delimited spray. The author goes through the steps involved on spraying this data. Once you spray the data, well, let's talk about what we're going to do next. I'm going to show you the ECL. Well, let me show you the ECL Watch real quickly. This is our training cluster that we like to use in our classes. It's a 3-node Thor, and you can see at the very top here that I have completed my spray operation of my yellow trip data comma-separated value files. So you can see they're stored and they are described and located on the ECL Watch. All right, so back over to my slide here. Once we've got the data, how do we work with it? And I like to call this the trilogy of working with any data on any HPCC cluster. Number 1, we spray the data, and I've just described that process. Number 2 is defining the record structure. And we're going to take a quick look at that in just a moment. And then number 3 is locating the data on the cluster using a special statement in ECL called dataset. So once again, spray the data, get it from the outside world to the cluster, define the data using a record structure, ECL record structure, and then number 3, we create a data set statement. All right, so what you see on the left side here is the actual record structure that is shown in the ECL watch. I can show you that very quickly by selecting either one of these files that we sprayed. I can go into the ECL tab of that particular file, and there you see it, the same default record structure with field names ready to go and all defaulted to variable length strings. Now we're going to do something with that in the remainder of this hour, right? So that's what we have on the left side of the slide here. And then on the right side of the slide is my module structure that I've created with the literally copy and paste that record structure and call it a layout. And then my data set that points to those files that we sprayed in the previous slides. And you can see I've got 2 data set statements because I've got 2 files. All right. Now, we have 2 files that we want to work with, but we want to still work with this data as one particular file. So one of the techniques that the author, Richard Taylor, talks about in his book is the concept of superfiles. And there is a great description of superfiles in his book and how to work with them. Superfiles are essentially containers that allow you to attach files that have the same format and the same type and reference them as a single logical file. And so there's all kinds of ways to do that. In our training classes, we have actually some exercises that work with superfiles and work with the superfile libraries. But I'm going to make things a little bit easier. Instead of using the standard library reference, and instead of referencing the programmer's guide right now, I'm going to show you an easy trick that actually Richard had pointed out in his book, and I forgot it was even there. So this technique is called using the ECL watch to create your superfile. It's there, it's ready to use, it's built in, and it's very, very easy to implement. So the last thing that I did here to get the data set up for our profiling coming up right now is I created a superfile. And how I did that was, first of all, selecting the files that I sprayed, these 2 CSV files. And then I select the option here that says add to superfile. There it is. I created a brand new superfile. I put the superfile name called DG : yellow trip data superfile, which was described in Richard's book. And I added it to my ECL watch. And the beautiful thing about this, there it is. There's my super file. There's the 2 files automatically attached. And now I can work with this super file. Well, going back to my slide, I add a new data set statement here that now points to the super file. Remember, the rule of super file is that any files attached to that super file have to have the same layout and they have to have the same format. And so this satisfies those rules. And so by referencing this superfile name, I not only reference one of the files that I sprayed, but actually both of them. So that's getting the data to the cluster. That's spraying it. And by the way, just real quickly, in my ECL IDE, I've got a little BWR file here that's showing me that referencing the name of my superfile, I've got my data here ready to work with. And from here, I'm going to go and hand it off to my colleague, Hugo.
Okay, thank you, Bob. And now that we have our data in the HPCC systems environment and have defined it for use, the next step really is to explore the data to discover what's what, right? And whether you're doing standard ETL processing or any other data work, you need to completely understand the data you are working with, basically for 2 primary reasons, right? First, so you can craft the best possible data structures for your end product or your end result database. And secondly, to make your data transformation processes as efficient as possible, right? So the first step in any data ingest process once the files are available in your cluster, is to profile the data. And this section discusses several possible ways to accomplish that task. Okay. First, there are some questions that we can ask about each field. And here are some of the initial questions for each field. Of course, depending on your type of data, you might need additional questions answered, but this list is quite a good start. So we can have, for instance, questions like these. Are there any non-numeric characters in the field? Or in other words, is it just text data or just numbers? If it's text, what's the maximum text length? If it's numeric, are the values integers or floating point? If it's numeric, what's the range of values? How many unique values are present? What do the data patterns look like? Or even how skewed are the data values and how sparsely populated they are, right? So let's look at some code examples to answer these questions. Let me look at this BWR profile 0.ECL code that is provided by the author of the book and see what are some interesting ways to answer those questions using ECL. So I have here a very basic initial code development to answer those questions. And I will start covering in details each one of those code structures. And over time, we'll be working with more advanced examples, right? So as usual, I start by defining all the libraries or external references that I might need on my code using the import statement. And we are also doing two redefinitions here just to make the code more easily maintainable and for easy reading of the code, okay? Nothing special there. But when we look at the first question here, are there any non-numeric characters in the field? Here is an interesting way you can address that question. First, you can start by establishing what are the valid numeric characters you want to evaluate on your data set. And here we are just passing a couple of digits, point and comma as possible numeric characters. And then we are using the substitute included standard library to actually parse the field that we are trying to assess here and filtering out or replacing any of those numeric characters by an empty string. That way, if I just have numeric values or numeric characters in that field, everything will get replaced by an empty string. And I'm using that Boolean condition or that result to evaluate a Boolean condition where the data set will be filtered, and if there are no or any values coming out from that filter are different from an empty string, my exist function will return true because I would have at least one record coming out from that Boolean condition. Check. But here is an interesting thing. Since we're using negative logic on the exist function, actually this entire piece of code will return true in case everything is numeric. And that's why I'm calling the definition is numeric. And last but not least, we are just outputting the is numeric value and see what we get. So if I just switch over to the first result here, we can see that actually that field that we are parsing or analyzing contains only numeric values, okay? Now, moving into the second question, this is basically an extension of the previous one. We're using an if function to validate in case the field is not numeric. It will check the max length of that field, because if it's not numeric, then it might be a string. But if it's numeric, we are just returning 0. And since we know this field is only numeric at this point in time, if we look at the result of that output, we can see here the text max length is indeed 0, okay? The third question here, if it's numeric, are the values integers or floating point, can be answered using an extension of the previous question. Here we are building a Boolean condition using the AND logic. So if the Boolean condition is numeric and exists any record as a result of the filter we are applying here, and in this filter, we are basically asking or using a library that will check if the field value contains a dot, which could be an indication that the number is floating point. But again, if that result returns anything different from 0, we are combining those two Boolean logics to return the output. And since the compiler is clever enough here to evaluate the AND operator, it will just check the second portion of this Boolean condition in case the first one is true, right? So if we look at the result of the third question, it's false. So we just have integer values at this point in time, okay? All right, so we know the field is numeric. We know it contains only integer fields, but what is the range of the values? And here we have a very simple usage of the min and max functions. We are just looking at the data set and evaluating what's the min and max values for the field being assessed here. So if we look at the result here, the min value is 1, and the max value is 2. So we actually just have 2 values, 2 integers on that entire field for the entire data set. Okay. Now, fifth question is a little bit more tricky and interesting in nature. So how many unique values are present, right? And we can get that answer by doing a group by via table function. So here we are just passing the entire data set, and we are specifying the record structure we want to see as an outcome of the table function, only 2 fields. But the interesting aspect here of this table function is that we are using a group by logic on the field being passed or being analyzed here. So that will give us a tabulation of the unique groups contained on that field. And we are just counting how many records we have resulting from that record set, because that will give us the number of unique values, right? So if we look at the vol count, again, we just have 2. Remember, values 1 and 2, okay? Moving into the 6th question, what do the data patterns look like? Well, you can see here that the author has started exploring some regex replace functions. So the first definition here at the top is looking for any alpha characters in that particular field and replacing them by uppercase X. And the second definition is actually looking at any numeric values between 0 and 9 and replacing the previous definition by a single 9 value, okay? Once that is done, you can vertically slice that data set and just expose the outcome of the nested regex replace functions. And last but not least, you can again group by your patterns that were resulting from the regex replace functions, so you can see and remove any duplicates on those patterns. Last but not least, you can sort the result in descending order from the pat count that was grouped on the previous table function. So let's see how many patterns we have on that field. As you can see here, we just have a single numeric value on that field, and this is the pat count for that result, okay? And then last but not least, if you want to see how skewed are the values, the author is here proposing us to use the top N function that you can see as a combination of a sort of the field being passed here, and you are now actually sorting the group count field in descending order and picking the 10 values at the top. So you're just getting actually the top 10 values on that field. And you have here an interesting function that will calculate the percentage of the values you have on that data set as an 8-character string with 4 decimal places. And last but not least, we have a table function here acting as a vertical slice on that resulting record set. And we are interested in seeing the percentage values for each of the unique values from the field being analyzed here. Okay. And if we look at the result here, we can see that the values 1 and 2 have these respective counts, and their percentages are somewhat similar, around 45, 54%, with 4 decimal places as we instructed. Okay. So this is an interesting slide, in my opinion, because it shows how ECL, or how the primitives in ECL can support data analysis from different aspects. And that's a very interesting aspect of how ECL is data-centric, in my opinion. Okay. Now, so even though we have ECL code now capable of profiling one specific field, which is the case we just noticed, and because we started our profiling code with the first 2 redefinitions, you could just change the FLD definition expression to name a different field and rerun the code. That would work, but that means the information would be in separate work unit for each field, and each question's answer would show up in a separate result tab for the work unit. So I think the display wouldn't be terrible user-friendly, and we can try to solve that first issue. So the fact that all answers show up on separate results tab can be easily addressed by writing a function structure to contain all the answer code and produce all the results on the single tab. So let's look at this profile.ecl code and see how that can be done. Okay. So if we tab over back to the ECL IDE, let's look at the profile.ecl file. And much of this code should look familiar, since it's basically the same code we just wrote. But now we are focusing more on code organization skills, plus displaying all the results in a single tab. Okay. So a couple of things that call our attention here. First, we are using a module structure to encapsulate all the related exported definitions that we want or we have. And one of those exported definitions is actually the layout of how I want to see the results displayed for each field of the original data set. So I'm just passing each profiling information as a separate field, with exception of the patterns and the data skill table, which we have seen might contain more than just one record. So we might want to do them as a nested child data set into the parent record. Okay. But most of the logic is still pretty much the same, and it's still contained within a record, a function structure now. And if we look at the parameters we are passing to this function structure, first, we're basically passing the data set, but we are actually doing a vertical slice here and just selecting the field that we want to profile. And the second parameter here is a string value that you can use. So it will make easier for you to see or output what is the field being profiling by this function. Okay. Apart from that, pretty much what we have in here are the same definitions that we were having on the previous code. Of course, there are some more enhancements for readability. For instance, the field type is now a string that returns a real string value if it's a real integer or a string. And we are also using map function down here on the value range so the results can look a little bit better on our end. But I guess the most appealing change is actually at the return statement of that function structure. We are returning a single record where each field is actually the profiling information from the field being assessed. Okay. So how do we use this function structure? So I have here a BWR that will show us how we can call that function. Again, I'm just importing all the exported definitions on my current module and doing a redefinition for easily maintenance of my code. And here are how the function calls would look like. I would basically pass the field that I want to profile and the string value of that field. And I could do that for several different fields from the original data set. Okay. Now, remember, we already have now a nested child data set on the output, so it is easier if we look at the result from that work unit directly on the ECL watch. And here is how that same profiling information would now look like in the end user interface. So I have each field from the original data set here and their profiling information all listed within the same record structure. Okay. Well, you might be thinking now, right? If you want to keep passing additional fields for this profiling function, you can just use Control-D and start duplicating each function call, replacing the field value and the string. That would okay, but wouldn't be much easier to let that work be done for you by the compiler? I think that's something the inventors of ECL always emphasize. So that's what we're going to do on the next slide. So the second issue of profiling every field can be resolved by using template language, which is a meta language to generate ECL code. Unlike ECL, the template language indeed has variables that must be explicitly declared and can be reassigned values. It is also procedural, meaning that you do have looping constructs and requires programming logic more similar to other procedural language than to ECL. So we can make use of that feature to automate ECL code generation to produce our profile function results as a single data set from every field in our original CSV file. So let's see how we can do that looking at this BWR profile2.ecl code. So let me tab over to the ECL IDE. And here you can see this is how the code now looks like using template language. So let's look at the code in more details here. First of all, this first section of the code should look pretty much familiar for you at this point in time. We are just importing everything we need to use and doing some redefinitions. Now, pay attention that we are now passing the entire record structure for the data set as the R definition. And we are also specifying the logical file name that will be generated as a result of this code, right? And we're trying to make that logical file unique by passing the today function, which will basically timestamp that logical file with today's date. Now, here is how template language looks like for those who might not be familiar with. You have statements that start with hash. So you can declare your symbols like XML rec. And you can also use hash export, for instance, to store the record structure from your R definition into that symbol. This is a very important function in template language or feature in template language because you can now see your record structure metadata is available on the XML rec symbol. So if we just submit this code, let's see how that looks like. You can see here, you now have an XML string and the metadata from your record structure is now available for you to be parsed as a simple XML file. For instance, the name of the field. Okay. Now, there are some other functions like load XML, which will actually close the scope of your subsequent statements into that XML stream. So we are just making sure all that we are passing after this point will be acting or processing the very initial XML string created by the export function. And here I'm just declaring a couple of more symbols, CTR and out string, which will be helpful for us to establish our logic of the template language code. And I'm using set statements to initialize those symbols with a specific value, in this case, 0. Now, I guess the interesting part of the template language code, as I told you before, is around the looping iterations that we can do. So here I have 2 for statements. The outer for is actually making sure I'm parsing the XML string that was obtained from the original record structure. And then for each field tag on that XML string, I am changing the value of my CTR symbol and incrementing that value by 1. I'm also using an if statement just to make sure that during the first iteration, I associate a specific value to my out str symbol. And my initial value, as you can see here, is just the string format of a ECL syntax. So I'm passing here the table function, and I'm extracting the name, the name of the attribute tag from my XML string to build this ECL code, which is still a string, okay? Now, after I'm done with the first iteration, I'm just using the append statement to keep building my ECL code using the append signal to concatenate the string values, and also using this control character, if you will, to make sure the code is changing the line as it's being built. Okay. Very well. After the 2 for statements are complete, they are marked with this AND statement. You can basically see the string value being generated or accumulated on that symbol, and you can actually see or execute the ECL code that is generated from that string value. So let's see how that looks like. And again, we might be able to see the ECL code on the ECL IDE. As you can see here, this is the string value of the code, and you can see that the field values have been provided in their correct places. But if you want to see the end result of the profiling information, again, we have nested child data sets. It's easier if we look at the resulting work unit on ECL Watch. And again, this is how you can see the profiling information once again. No changing on that aspect. Remember, we were just automating code generation at this point in time. Okay. All right. So, but now you might be wondering, okay, we now know how to run the profiling function on each field of the data set. I no longer need to duplicate my function calls, but I'm still tied to the same data set, right? Wouldn't be interesting in case I can automate this even further and run the same function for different data sets? So if you want to do that, you could wrap this code either in a macro or function macro structure, and that will give you a tool that you can just call, passing as an argument the data set to profile. And like the template language, both the macro and function macro are code generation tools. So let's look at this example here, fnmacprofile.ecl, that will show us how we can do that. So tabbing over to my ECL IDE once again, we can see that the code hasn't changed too much, except for the fact that we are now encapsulating everything in a function macro, right? And if you look at the parameter being passed to the function macro, I don't have a data type associated to it, because the function macro basically take tokens as input parameters. And tokens will just get replaced across the text of the code as they have been passed to the function macro. So it's just a lexical substitution here. And you can see the data set value that I pass as a token will be associated to the DS definition, and my R definition will now be the record structure of that data set. Okay. I'm also doing a slight change here because I'm no longer using hash export and then doing a hash load XML or actually a load XML function, because the hash export XML eliminates the need for the load XML function. So I'm just reading the content from the record structure and making sure it's associated with my XML out symbol. And from that point onwards, all the imperative or procedural characteristic of the logic, the code remains the same. And I'm also no longer interested on seeing the string value. I'm just interested in seeing the result of the ECL code being generated or executed. So I'm just going with a return statement in the symbol value itself, not the string value of the symbol. Okay. How do I use this code? Okay. It's a function macro. I need to call that function macro. So that's why in our repository here, you have a BWR test.ecl, which will call that function macro. So I'm just showing you here how you can pass the entire superfile that Bob just created as input for the profile function. Okay. And if you look at the result of that profile function, once again, no major changes in that area. It's just the profiling information once again, but now you can pass different data sets and the template language code will extract the record information, the record structure information from that data set, right? So, and you can go on. This is not the last stop, actually. You could try now comparing results from periodic updates, right? You now have the capability of using the function macro to call different data sets. So here we have, if you do face the need of periodically receiving new files and add them to the collection you already have, that's really a good idea to rerun your profile code on the new file to see if there are any significant differences in the data. And those differences that might require changes to your processing code or finite product data format to handle. So we can see how we can tackle that easily. And to emulate that process, let's check this BWR profile compare.ecl code that will show us how we can do that. Okay. So tabbing over to my ECL IDE, this is actually a simpler code compared to what we have seen so far. So I'm just using here two definitions associated with the logical file names from each of those data sets. And I'm here emulating that I might be receiving a data set on different days of or different months of the year. I'm here specifying two definitions where the FNMAC profile is being called for each data set. And then I'm doing or starting two definitions or two data set declarations on top of the logical files being generated by the profile function. Remember, all the profiling results we were seeing up to now have been stored in a logical file. And then I'm just appending those two profiling results and sorting them by field name. So all the field names that are the same will be grouped together, and that will make things easier for you to inspect. So you can just do an output, an implicit output here. our definition. And the sequential action will take care of us making sure everything happens on the proper sequence. And again, if we look at that result, now you can see profile 1, profile 2, and the comparison between the two profiles. You can see here, field names are duplicated, and you can actually compare the results from each data set, okay? And the same happens for all the other fields. All right. Well, this is pretty much we were planning to show around profiling. Of course, if you look at the book, you can move forward. You can actually automate the profiling comparison, so you're not relying on human reading to see those or to compare those results. But since the focus was presenting the foundational aspects of ECL and how they can be used for profile, at this point in time, it might be a good idea to look at some other development tools around for automating data profiling in HPCC systems, okay? So that's why on the next slide, just to wrap up, I will mention the data patterns built-in data profile. Because the data patterns is an open source add-on bundle for everyone to use that was originally created by Dan Kemper, one of our most distinguished community members. It proved to be such a useful tool, actually, that this bundle has now been incorporated into both the ECL standard library and ECL Watch. And that means there are 3 ways to use data patterns. The one I'm showing right here on the screen via the data patterns tab in ECL Watch, via the bundle, if you deploy that bundle directly from GitHub, and from the standard library reference, just using the STD data patterns reference, right? Now, all the 3 ways invoke data patterns produce the same result in terms of data content, but there are slightly differences in how the information is displayed for you visually. I will just quickly show to you how the data patterns can be invoked by using the option 2 here, the bundle. So if you go to the BWR test, I will just comment this one and highlight the 2 last lines of code. You can see here I'm porting the data patterns, and then I'm using the profile function on top of my super file. So I'm passing my super file as an input for the profile function. And what I will see on the ECL Watch, hold on, it's a very interesting visual profile report from each field of the data set, okay? So that gives you a much more visual aspect, not only around the field contents, but the distribution of the field values and so forth. And you do have, if you're interested, in a much more detailed raw report from data profiling that you can traverse to really understand what's the content of your data, okay? So I'll stop here. I have shown you guys several different ways of doing profiling of your data. You can do that using ECL code, using the primitives, or you can use data patterns. Now, from this point onward, Bob will take some of that information to define our cleaning and standardization strategy. So I will now hand it over to you, Bob.
All right, thank you, Hugo. That was great. And we've got just a bit of time left over here. What do we do with all that information once we understand every bit of field, the maximum, minimum values, the lengths and all that stuff? Well, now we can start to apply that to our actual input data set and transform that data set into a better data set by a lot of different things. First of all, the importance of sequencing, the importance of adding a global unique identifier to each input record. That way, when new records come in, we can always, match that with new data coming in to see if that data just needs to be replaced or if it's a brand new element that needs to be replaced. So global sequencing, we talk about this in our ECL classes, and also the ability to get back to the original input. So we have tracking here. So there's a lot that goes on here. When we talk about global context, we talk about your input data and what we're going to do with input to output. I'm going to take advantage of one of the functions that is built into the data patterns that Hugo was talking about, called best record structure. And it's real simple. I just take the original input data, which had raw variable length strings, as you remember, and then I'm outputting this as a best record structure, and there it is. So I can zoom in on this. You can see I've got recommended best field values for each one of the fields in my original input data set. And over to the right here, you'll see that I've got a new file called taxidata.ecl, which is now applying these best record values into my modified record or my improved record. Now notice there's also a record ID. I'm going to get to that in just a moment. So also things like date and time. Well, we actually have a new date and time field, drop off date and time field, just pull them in using the date and time format from our standard library, which is important because we can take advantage of built-in date and time functions that are part of ECL. So you can go through the rest of this. You can see the only other thing I want to mention here is the best record recommended reals, and we're converting them over to decimal 9_2 because we're working with numeric amounts which have dollars and cents. So we don't have to have floating point values here for fair amount and taxes and tips and things like that. Since we're working with monetary values, we can change these reals into a more efficient storage method of a what we call a decimal value type in ECL. All right, so in order to do our sequencing, there is a built-in macro. Let me just pull this back over to the previous tab group. And this built-in macro, well, here's the taxi data once again. The built-in macro is called macro gen UID. And I thought this was a very clever implementation of the author. The author said, well, how am I going to, number one, sequence my records? And most people studying ECL and reading about ECL know that the best way of sequencing records is a transform function called the project. And so we talk about this in class. We also talk about in class that project with a counter would do the job, but it would give you kind of a sequential semaphore type of numbering where one node would get filled up, then node 2 would get filled up, node 3 would get filled up. So in order to alleviate that, we initialize local operation for the project, which again ensures, well, we need to start the first node at node number 1, and the second node at node number 2, and the third node at node number 3. So we've got a formula here that we're using to calculate this numeric sequence. And once again, this is something we've talked about in our ECL online lessons and in classes. And so the author of the book just decided to take this project with local and add it and wrap it around, well, a function macro. And also, what the author did was read the super files based on an input that we give the macro. And in this example, the input is this thing called UID file prefix. So my super files have a special global ID identifier, and this macro then goes through using one of our standard functions again. No Thor, meaning that we don't want this to happen on every node. We want this just to access the distributed file utility and only give us one result. So it operates this function inline. And then we read by doing some parsing, some clever parsing through that prefix, and we get a starting number based on maybe the last time that I ran this. Now, if it's the first time I ran this, then start should be 0 + 1. And that's what actually starts to happen here. So in this project and inside of this transform, you've got the start plus the next record, which is that numeric formula, which was doing my local sequencing. Putting this all together, showing you how this is implemented, we have this call to the function on line number 8. So you can see I'm passing it the superfile input with a filter to make sure that we're only converting records that have a valid vendor ID. And the reason is that there's that embedded record in there in the attached subfiles that have the field information. So we want to bypass that. So we say, as long as the vendor ID is not a string, then I want to grab that as a valid record. The rest of this, we decided to split our dates into dates and times. This technique down here inside the record structure of the transform is doing something called explicit casting. So all of the field values in that record structure that we had in taxi data over here, we're just simply applying that to this transform and casting it to those field values. And then a simple project, a simple output. And now from our original input, which was way back here with the test data, we've now added in our output clean data a record ID starting at number 1, the vendor ID, and then the dates and times split up into their appropriate field values. And again, all of the other field values normalized and given us a more efficient storage form than the original variable length string. All right, so to summarize with this file format we took and standardized using a project. We started with the best record structure. And then in taxi data, we pretty much emulated that record structure through the recommendations. The only thing we did was, instead of using reals, we used decimal fields. And then we then ran the transformation, applying it to our auto numbering macro, and then casting the original variable length string values of the original record structure into the appropriate numeric fields and date and time fields that were better storage and more efficient, and in the long run faster. And again, the author in the book talks about this. He says, why bother to haggle over 1 or 2 bytes per field? And then he mentions very clearly that if you're working with a small data set of several hundred records, but then if you have several hundred billion records, well, then it becomes much more significant. And then we have a choice. So once we've cleaned this data, now you have 3 choices. Despray it back to the original landing zone and give it to the vendor. Use a SQL web service to allow people to access the data on the cluster from an external SQL-based source. Or number 3, which is what we're going to talk about in hour number 2, starting tomorrow, create end user queries and publish them to Roxy. So I'm going to withhold discussion on number 3 because that's going to be the content of our second hour tomorrow. Taking this clean data and delivering it to our customer in the most fast, efficient, and most accurate way possible. So that concludes our first hour. Once again, thank you very much for listening and attending. It's been my pleasure. Yuko, thank you so much for your part. Here is the link at the bottom to our GitHub repo to download the code we've talked about. And there's our email if you want to email us with any questions during the community day or even after that. We're here and available for you. So until tomorrow, thank you so much for listening. Until then, have a great day, everybody, and we'll see you at the next workshop. Thanks.